Have you ever had to ask someone next to you to adjust the AC while driving? Have you ever forgotten which button does what in your new car? If you're over 55, there's one truth you need to understand right now. According to a 2024 survey, 68% of older drivers admit they feel stressed by complex menus in modern vehicles. That's not your fault. That's design failure. Now, before we go further, let me be very clear about something. Tesla has never officially announced a vehicle called Model 2. Everything we're discussing today comes from leaked engineering documents, industry analysis, and insider sources close to Tesla's development teams. While we can't confirm these details with 100% certainty, across patents, supplier chatter, and repeated reporting from multiple outlets, the story is pointing in a similar direction. This video analyzes what could happen if these leaks prove accurate, not what Tesla has promised. What we do know for certain is Tesla has publicly discussed a next-generation, lower-cost platform. The open question is what form it takes and whether it hits the rumored targets. The leaked price point is $12,749. By the end of this video, you'll know exactly what to believe, what to question, and most importantly, whether this technology actually serves you or just sounds good in a press release.
The real enemy when you drive. Let's talk straight about what's wearing you down every time you hit the road. First is the overly complicated user interface. You know that feeling when you have to swipe through 3 menus just to adjust the temperature? I talked to a retired veteran in Texas, 67 years old. He sold his 2024 luxury sedan after 6 months because he couldn't turn off lane departure warning without going through 4 screens. The right design principle is see it to use it, not memorize it to use it. Multiple studies show that drivers over 55 take significantly longer to complete basic tasks on touchscreens compared to physical controls. That extra time means your eyes aren't on the road. At highway speeds, you've traveled over 300 feet blind. Think about that. 300 feet is longer than a football field. In that distance, a child could step into the street, a car could brake suddenly, a dog could run across. All while you're looking down trying to figure out which icon adjusts the fan speed. The feeling of technology stealing control is worse. Ever had lane-keeping assistants pull your steering wheel back when avoiding a pothole? A driver in Florida told me her new car beeped 17 times on a 10-minute drive to the grocery store. For older drivers, this isn't assistance, this is intrusion. It's the car questioning your judgment, second-guessing decisions you've made successfully for decades. The worst part? You can't turn most systems off permanently. Disable them for one drive, but next time you start the car, they're back on. But there's a quieter enemy: hidden costs. The average gas car costs $1,200 per year in maintenance. Over 10 years, that's $12,000. Add fuel costs, you're looking at another $15,000 to $20,000. Gas cars lose 60% of their value in 5 years. When you add it all up, that number isn't just money. It's time, effort, and stress every time the warning light comes on.
What Model 2 is really saying to you? So where is this rumored Tesla different? According to leaked internal specifications, this isn't a car that introduces the future. This is the car that saves you from current annoyances. Sources close to Tesla's development suggest Model 2 is being designed with the immediate access philosophy, meaning critical operations would have physical buttons, not buried in touch menus. Turn on AC? 1 button. Adjust mirrors? 1 knob. Hit emergency lights? 1 large red button right in front of you. Tesla learned from customer feedback on Model 3 and Model Y. People complained that too many functions were touchscreen only. If Model 2 wants to serve older drivers, it must fix that with dedicated physical controls for climate, volume, hazard lights, and window defrost.
Industry estimates suggest the target floor height is around 680 millimeters, roughly 15% higher than traditional sedans, but lower than SUVs. If you've had knee surgery or back pain, you know what I'm talking about. An orthopedic surgeon I spoke with, who specializes in elderly care, told me the ideal entry height for seniors is 650 to 700 millimeters. Model 2 would sit in that sweet spot. Door opening angles, likely around 72 degrees instead of the typical 65 degrees, would create space to turn comfortably. Think about getting groceries. With a wider opening, you can enter naturally, place bags on the passenger seat, then sit down without contorting yourself. Lower door sills, likely around 4 inches compared to 6 to 7 inches on most SUVs, would mean less lifting your leg, less chance of tripping. Four-way adjustable steering wheel means whether you're 5'2" or 6'4", you find a comfortable position. These are projections based on leaked engineering documents and current Tesla design language. Final specifications may differ when the vehicle launches.
What you actually get. Let's talk about engineering in ways you can feel immediately. First is the button system and instant operations. When you need to adjust temperature, you don't need to find a menu, don't need to open an app, don't need to ask a virtual assistant. You just turn the knob. This reduces cognitive load during operation, helping you focus on the road instead of wrestling with the interface. Research shows that every second your eyes leave the road increases accident risk significantly. Good design keeps your eyes on the road. Here's a real scenario. You're driving on the highway, sun comes out, you're getting hot. In a modern touchscreen car, you tap the screen, wait for it to wake up, find the climate icon, tap it, wait for the submenu, then adjust. 6 steps, maybe 8 seconds of distraction. In a car with physical controls, you reach for the dial without looking, turn it 2 clicks cooler. 1 second, eyes never leave the road. That's the difference between safe and dangerous design. Next is driving position and visibility. Seats high but not too high. Doors wide but not bulky. Windshield large but creating no blind spots. You don't have to step down like from a truck, nor crawl in like a sports car. You just sit down and drive. Simple as that. But few manufacturers get it right. The benefit? You travel without pain, without worry, and actually want to drive more. When getting in and out of your car becomes a chore, you stop going places. When it's effortless, you maintain your independence longer. And here's what most people ask about. If the car loses power, how do I open the door? According to standard Tesla safety engineering practices, Model 2 would have a mechanical backup door release. You pull up slightly and the door opens immediately. No battery needed, no electricity required. It's simple, it's reliable, and it means you're never trapped. This isn't a special Tesla feature, it's basic safety engineering that should be standard everywhere, but often gets buried in complex designs. This focus on physical controls isn't nostalgia, it's responding to what you've been asking for. One of you put it perfectly. Touchscreens are fine parked, not at 65 miles per hour. Exactly. Across hundreds of comments, the message is clear. You want buttons back for essential functions. You want technology that helps when you're tired, but doesn't force you to navigate menus at highway speeds. And you're absolutely right to demand this. The best technology should be invisible, working for you without demanding constant attention.
But here's where enthusiasm meets reality. A car with perfect buttons means nothing if you can't afford to fix it after a fender bender, or worse, if it doesn't protect you in a real crash. Let's address the 3 questions that actually determine whether this vehicle works for you, not just in the showroom, but 10 years down the road. The 3 questions real buyers actually care about. Before we dive into technical details and manufacturing specs, let me ask you 3 questions that matter more than any promotional video or press release. First question, and this is critical for anyone over 55. Can you actually get in and out of this car without help?
I'm not talking about a 25-year-old with perfect flexibility. I'm talking about you. If you use a cane for stability, if your back isn't what it used to be and bending causes pain, if your knees complain every morning when you stand up, can you slide into this vehicle without struggling? Door geometry, seat height relative to your hip level, the turning and twisting motion your body has to make, these aren't minor comfort details. For many older drivers, these factors are absolute deal breakers that determine whether a car is usable at all.
Second question, and this one hits your wallet directly. If someone bumps into you in a parking lot, does that small dent turn into a financial disaster? This is the question that keeps insurance companies up at night and should concern you even more. We're talking about repairability in the real world, insurance rates that compound over time, the total loss threshold, where your insurance company runs the numbers and decides it's actually cheaper to write off your entire car than repair the damage. A vehicle at the leaked sub-$15,000 target can cross that line frighteningly fast with damage that looks minor to your eye. Third question, and this one's about your physical safety on the road. Is a small, lightweight car actually safe when you're driving next to Ford F-150s and Chevy Suburbans that weigh twice as much as you do? We need to talk about structural integrity that protects the cabin during impact, crumple zones engineered to absorb energy properly, cabin protection that keeps you safe when physics says the bigger vehicle has the advantage. If Tesla can't answer these three questions convincingly with real data, not marketing promises, then everything else they're talking about is just noise and speculation.
The door reality. Beautiful doesn't mean functional. Let's talk about those doors everyone's excited about, because there's a big difference between a door that looks impressive and a door that works in the real world. There are two concepts people constantly confuse. Side clearance is how much space the door needs when fully open. Swing path is the arc the door travels through. You can have a design that looks like it opens wide, but if that swing path extends into the neighboring space, you've got a problem in crowded parking lots. Based on patent filings and test vehicle observations, engineers have ways to reduce this risk. Multi-axis hinges that change the door's trajectory, sensors that limit how far the door opens based on detected obstacles, two-stage opening systems where the door cracks open just enough to check clearance before swinging wide. But here's what matters more for someone over 65: accessibility. The ideal seat height allows you to stand next to the car, rotate your body, sit down, then rotate your legs inside. No bending, no twisting your spine, no dropping down into a low seat or hauling yourself up. If leaked specifications are accurate and Tesla is serious about building a car for older drivers, this is where the engineering must focus. A door that goes viral on social media is worthless if it causes you back pain every time you use it. Repairability and the total loss trap. This is where we need honest conversation about what happens after an accident. Why do affordable cars become total losses so quickly? Insurance companies calculate total loss based on labor hours required, wait time for parts, whether the frame is damaged, and the safety risk of driving a repaired vehicle. For a vehicle at the rumored entry price target, you can hit that threshold with surprisingly minor damage. Designing for repairability is completely different from designing for manufacturing efficiency. A successful mass-market vehicle needs panels and parts that can be replaced individually, a structure that can be realigned without specialized equipment, standardized components, and repair procedures that work at independent shops, not just Tesla service centers. This concern is showing up repeatedly in comments. Will a small crash total the car? What about insurance rates for a $12,749 vehicle? These are exactly the right questions to ask. Based on Tesla's current approach to serviceability, the answer depends heavily on how they design the Model 2's structure.
Those special doors, they're expensive to repair because of hinge mechanisms, sensors and actuators, and complex alignment procedures. If Tesla wants Model 2 to be a true mass-market vehicle, they need to prove one thing: a minor fender bender won't generate a $10,000 repair bill. Think about it. You're on a fixed income. Social Security provides your monthly budget. You get rear-ended at a stoplight, nothing major, but because of how the car is designed, that impact damages structural components that can't be repaired, only replaced. Suddenly, your car is declared a total loss. Your insurance pays the depreciated value, which might be several thousand less than what you still owe. This scenario isn't hypothetical. It's happening right now with several electric vehicles.
Safety and structural integrity. Surviving in a world of bigger vehicles. How does a small, lightweight electric car protect you when surrounded by 3-ton pickup trucks and massive SUVs? 3 engineering factors determine crash safety. First, crumple zones that absorb impact energy by deforming in a controlled way. Second, load paths that direct forces around the passenger cabin rather than through it. Third, cabin integrity, a protective cage that maintains its shape even under extreme stress. Here's something that surprises people. A stiffer car isn't always safer. You need the right balance of energy absorption and structural rigidity in the right places. Based on Tesla's established engineering approach, they can't simply copy crash performance from Model 3 or Model Y into a smaller vehicle. The physics don't work that way. However, they can leverage their design philosophy and simulation experience. Tesla has run thousands of virtual crash tests. They understand how to optimize structures for multiple impact scenarios. That knowledge transfers. But here's what you need to remember. Until we see actual crash test data from the National Highway Traffic Safety Administration and the Insurance Institute for Highway Safety, everything else is speculation. Those ratings are the only objective measure we have. Marketing videos don't protect you. Engineering simulations don't protect you. Independently verified crash test results protect you. So, we've established that physical buttons matter, entry-exit matters, and crash safety absolutely matters. But none of this means anything if the economics don't work. Let's talk about the number everyone's debating, that $12,749 price tag. The price breakdown from $12,749 to real-world cost. Let me show you how the leaked price target translates to real-world ownership costs. This is a best-case scenario analysis. Actual results will vary significantly based on your location, driving habits, and available incentives. Start with that rumored MSRP. State incentives vary wildly. California offers $2,000 to $7,000 in combined rebates. Colorado gives $5,000. Texas and Florida offer $1,000 to $3,000. In a high-incentive state, you might capture $3,000 to $5,000, dropping your out-of-pocket costs to around $8,000 to $10,000. But remember, incentives change with political administrations and budget cycles. Don't count on them being permanent. Now factor fuel savings. If you drive 12,000 miles yearly at $2.89 per gallon for gas, you're spending roughly $1,500 annually. Switch to home charging at 17 cents per kilowatt hour, your annual cost drops to around $600. That's $900 saved per year, or approximately $6,300 over 7 years, assuming stable electricity rates and consistent gas prices, which is optimistic. Maintenance is where EVs have a genuine advantage. No oil changes, transmission fluid, spark plugs, or exhaust systems. EV maintenance typically runs $200 per year versus $600 to $800 for gas vehicles. Over 7 years, that's potentially $3,000 to $4,000 saved, though battery degradation and tire wear from instant torque can offset some savings. Here's the realistic bottom line. If you capture maximum incentives, drive efficiently, and maintain the vehicle properly, your total cost of ownership over 7 years could be competitive with or lower than a comparable gas vehicle.
But calling it negative cost or claiming the car pays you back is misleading. You're still spending money, just potentially less than you would on alternatives. The real question isn't whether this car is free. The question is whether it delivers reliable, affordable transportation that doesn't drain your retirement savings through constant repair bills and gas station visits.
Why Tesla needs this vehicle. Tesla faces brutal competition. BYD commands 15.7% of global EV market share. China proved you can mass-produce quality EVs under $20,000. Meanwhile, American buyers want electric but can't justify $40,000 up front. According to industry analysts, Tesla needs this entry product to feed their robotaxi network. Cybercab production reportedly targets Q2 2026, but autonomous fleets need hundreds of thousands of human-driven Teslas mapping roads first. The pressure is immense. Every month Tesla delays, BYD captures more mindshare. This isn't just about one affordable car, it's about controlling the entry point to electric mobility for the next decade. Whoever wins the budget segment wins the volume game.
Engineered to survive, durability and hidden costs. Water and corrosion kill more vehicles than dead batteries. Over 40% of Americans live within 50 miles of coastlines or in regions with 3 to 5 months of road salt annually. Salt spray, brine runoff, and standing water destroy suspension, wiring, and battery enclosures over time. According to leaked engineering specifications, this affordable model is being designed to survive what totals most EVs. Battery pack and drive units would feature ceiling rated for 3 feet of standing water for 30 minutes. That's designed for heavy thunderstorms flooding intersections, not off-road adventures. Average city curbs sit 6 to 8 inches high. Flood warnings become dangerous at 12 inches. If these specs prove accurate, Tesla designed for triple that depth, covering virtually every urban scenario. Based on industry analysis of Tesla's manufacturing approach, corrosion protection separates Tesla from budget competitors. Advanced anti-corrosion coatings would cover every underbody component. Standard economy cars survive 500 hours in salt spray testing before rust appears. Leaked targets suggest Tesla aims for over 1,500 hours, translating to 5 to 8 additional years in Michigan, New York, or Minnesota, where roads stay salted half the year. What does this mean? Fewer seized bolts at 120,000 miles, fewer cracked brake lines, fewer suspension failures. If the leaked design documents are accurate, the platform includes guided drainage channels, moving liquid away from sensitive areas within seconds. Trapped moisture corrodes, drained moisture doesn't. Industry estimates suggest strategic use of aluminum and coated alloys could cut 150 to 250 pounds versus steel competitors. Less weight means less suspension stress and better long-term durability. Based on Tesla's established thermal management systems, active cooling maintains optimal battery temperature year-round. Batteries degrade 20 to 30% slower than passively cooled competitors. Over 10 years, that's the difference between 80% capacity and 60%. Durability engineering sounds impressive on paper, but here's what really matters. Can you afford to own this car for the next 10, 15 years? Let's look at the total financial picture, not just the sticker price, but everything you'll spend keeping this vehicle on the road.
Why the current car system always drains your wallet. Let's be honest for a minute. You don't change oil because you enjoy it. You don't take your car in for inspections because you find it exciting. You do these things because the entire automotive system is built on one simple reality. Gasoline cars need constant maintenance. And every time you walk into that garage, this system makes money off you. Older folks like us typically don't finance cars. We pay in full or close to it. We keep cars longer, drive more carefully, maintain them on schedule. But that's exactly why this system accumulates costs over the long term. Every year you keep that car is another year you pay for gas, oil, air filters, brakes, tires, and hundreds of other parts.
Now, I've seen some exaggerated claims about maintenance costs running $700 monthly. That's not typical for well-maintained vehicles. But here's what is true. Over 10 years, the average gas car costs between $1,000 to $1,500 per year in scheduled maintenance, plus another $500 to $1,000 in unexpected repairs. Add fuel costs of $12,000 to $18,000 over that same period, and you're looking at real money, $20,000 to $30,000 that simply evaporates.
What Tesla is really targeting? Longevity. Most people think Tesla makes fast cars for young tech enthusiasts, and they're right, partly. But according to industry analysis of Tesla's engineering approach, they're pursuing longevity. Not 1 or 2 years longer, but 10, 20, even 30 years without needing to replace major components. Leaked internal documents suggest the Model 2 is built on a principle Elon Musk once stated: the best part is no part at all. Sounds like a marketing slogan, but think about it. An internal combustion engine has over 2,000 moving parts. Each part is a potential failure point. Tesla's electric motor? Only about 17 main moving parts. That's not a minor improvement. That's a complete transformation in how cars work. The rumored Model 2 pricing ranges from $12,749 to potentially higher depending on version and market. These figures remain unconfirmed. But if accurate, it could be the car that costs you the least over the next 15 years. If you don't care about accelerating from 0 to 60 in 3 seconds, if you just want a car that takes you from point A to point B without emptying your wallet, then this rumored vehicle is finally designed for you. The battery, the biggest fear, and why Tesla had to solve it. Everyone fears their phone battery dying after 2 years, so why wouldn't they fear an EV battery? They do, and that's why this is Tesla's #1 priority. If the battery dies after 5 years, the entire value of the car collapses. You can't sell it, you can't use it. You're stuck with a metal block worth thousands in replacement costs. That's financial disaster. This is why, according to industry analysis, Tesla is exploring several advanced battery chemistries for the next-generation platform. While specific chemistry hasn't been confirmed, the focus appears to be on durability under real-world stress. Based on Tesla's current battery warranty structure, you can reasonably expect around 8 years of coverage, which is standard across Tesla's lineup. The engineering approach likely focuses on distributing charging stress more evenly across cell structure, reducing long-term damage from repeated fast charging sessions. Here's what matters most to daily drivers: temperature resilience. Industry analysis suggests battery designs being considered aim to operate stably across extreme temperature ranges. This addresses the moment when extreme weather turns from an inconvenience into a financial nightmare. If you live in northern Canada or Texas in summer, temperature-related battery degradation could cost you thousands in premature replacement. Realistically, modern lithium batteries in Tesla vehicles currently achieve 1,000 to 2,000 charge cycles before significant degradation. That translates to roughly 200,000 to 400,000 miles of driving, depending on battery size and charging habits. While new chemistries might extend this further, counting on dramatic improvements is speculative. Safety is another critical consideration. Tesla's established approach to battery design focuses on reducing fire risk through cell-level safety features and thermal management. While no battery is completely risk-free, current Tesla vehicles demonstrate strong safety records. This could translate to reasonable insurance premiums, adding another layer of long-term savings. Car price doesn't matter as much as 10-year price. Here's how most people think about car pricing. They look at the number on paper and decide whether they can afford it. But that's the biggest mistake you can make. Purchase price is only part of the equation. The real cost is the total amount you spend over 10, 15, or 20 years of owning that car. And that's where the rumored Tesla Model 2 could potentially save you significant money.
Say you buy a new Toyota Camry for $25,000. Over 10 years, you'll spend an average of $15,000 on gas, $3,000 on regular maintenance, $2,000 on unscheduled repairs, and about $1,500 on oil and filter changes. That's over $21,000, not counting insurance. Total, $46,000 for 10 years of use. Now consider the Model 2 at the leaked price of $20,000 for a higher trim version. Over 10 years, electricity costs estimated at $3,000, maintenance significantly reduced because there's no engine oil, minimal brake wear due to regenerative braking, no exhaust system. Even if you have to replace tires 3 times, that's only about $1,200. Total, approximately $24,000 for 10 years. That's $22,000 in potential savings, though actual results depend heavily on local electricity rates, driving patterns, and whether battery replacement becomes necessary. But here's what really matters: peace of mind. Not wondering every time you start the car whether today's the day something expensive breaks. Not budgeting hundreds every month for maintenance you can't predict. That psychological relief is worth more than any spreadsheet can calculate. Financial planning matters, but there's one more piece of this puzzle that keeps coming up in your comments: driver assistance. You want help when you're tired, but you don't want the car taking over completely. Let's talk about what full self-driving actually means and what it doesn't.
What FSD really is right now. Your comments have been crystal clear on this topic. Many of you want monitored self-driving and assisted driving when tired, but full control when you want it. You're asking exactly the right questions. So let me explain what Tesla's full self-driving actually delivers today. Not the marketing vision, but the real-world capability. Now, let's talk about full self-driving, the most controversial name in the auto industry. First, I need you to understand one thing clearly. As of early 2026, Tesla is still providing FSD at the supervised level. What does that mean? It means you still have to pay attention, still have to keep your hands on the wheel, still have to be ready to intervene at any moment. This is not Level 5 full autonomy. This is Level 2 advanced driver assistance, where the car assists you significantly, but the responsibility is still yours. In the latest updates, Tesla is pushing improvements in 3 main directions. First, better contextual understanding of the environment. Instead of just recognizing lanes, the system is learning to understand where sidewalks are, where parked cars are, where pedestrians might cross. This helps the car react more naturally, like an experienced driver anticipating situations. Second, more flexible stopping and parking options. The system is getting better at identifying safe places to stop beyond just staying in lane, whether that's parking lots, curbs, or driveways. Third, smoother handling of emergency vehicles. When it detects priority sirens, the car adjusts speed and position more naturally.
But here's what you must remember. This is still supervised. You are the one responsible. The car assists, it doesn't replace your judgment. Several comments asked, why is FSD supervised? Feels like it should be all or nothing. Here's why supervised is actually the feature, not the limitation. You get assistance when you want it, in heavy traffic, on long highway drives, when you're tired. But you retain control when situations demand it. You can override instantly. You can disengage. You choose when to use it. Think of it like cruise control, but far more capable. Nobody complains that cruise control doesn't steer for you on city streets. You use it when appropriate, disengage when it's not. FSD Supervised works the same way, just with far more capability. But the most important thing for you, viewers over 55, is that current FSD doesn't replace you as the driver. It assists. It doesn't steal control and push you away from the wheel. You're still the decision maker. The car is just a capable assistant. This solves 3 big worries. The worry that the car drives itself while you have no control, the worry of losing decision-making power when danger strikes, The worry of being completely dependent on AI that you don't know what it will do next.
Why FSD isn't fully autonomous yet, and why that's good. This question is very important, and I'll answer it straight. Tesla needs to collect data from billions of real-world driving miles before reaching the unsupervised goal. Currently, over 2 million Teslas are sending data every day. Every difficult situation helps the system learn and improve. This isn't pointless waiting, this is necessary for safety. By the end of 2025, Tesla had accumulated over 6 billion miles of FSD data. That's one of the largest real-world data fleets in the industry, with orders of magnitude more vehicles collecting data daily compared to competitors. But even 6 billion miles isn't enough for full autonomy. Some safety researchers argue it may take many more billions of miles to handle every edge case safely. Edge cases are weird, rare situations, like a mattress falling off a truck, a child running between parked cars, construction workers directing traffic manually. And here's the part most people miss. Supervised is not a limitation for seniors, it's the safety feature. You're still in charge. You have an assistant when tired, when driving long distances, when stuck in stressful traffic. But you still have control when you want to pass quickly, when you need to dodge suddenly, when facing unexpected situations. Think of it like an airline pilot. Autopilot on airplanes has existed for over 50 years, but pilots are always there, always ready. Nobody calls that a failure. That's safe design. Pilots use autopilot for 95% of flight time on long trips. They handle takeoff, landing, and unusual situations. Everything in between, the autopilot does the work. That's exactly how FSD works. If a system needs you to supervise it, that's not a failure. That's the honest stage of autonomy. The name full self-driving is misleading, I'll give you that. But here's what matters, what it actually does today. It makes highway driving less tiring, stop-and-go traffic less frustrating, and gives you an extra layer of safety through constant monitoring. You control when to use it. You control when to take over. That's exactly what your comments asked for.
The direct benefits for your daily life. Let's sum up what you actually get. Technology makes your life easier, not more stressful. You don't have to relearn everything like learning a new phone. The system is designed for you to understand it the first time. Imagine a real trip. You start the car with a button, no key to fumble with. Turn on AC with a dial. Adjust temperature with plus and minus buttons. Turn on music with a physical button on the steering wheel. Every action is one step, not 3 menus deep. Activate FSD by pulling the stalk twice. The car gives you a clear message. FSD activated. Keep hands on wheel. No ambiguity. The car guides you onto the main road, accelerates smoothly, maintains safe distance. When someone cuts in front of you, the car slows down automatically to restore safe distance. No sudden braking, no jerking, just smooth adjustment. When you need to change lanes, you turn on the signal, FSD checks mirrors, checks blind spots, and suggests when it's safe. You can accept or override. Your choice, always your choice. When you arrive, you tell the car, find parking. In many real-world cases where the feature is available, it scans the area using cameras and sensors. Within seconds, it highlights available spots on screen. You tap one, the car parks itself. Or you can park manually if you prefer. Everything smooth, clear, nothing ambiguous. This isn't science fiction. This is what's happening on thousands of Teslas every day. If the Model 2 leaks prove accurate, it would be optimized for people like you, people who need simplicity more than flashy features. No gimmicks, just reliable transportation that respects your intelligence. Here's what matters in daily life. When you start to drift out of your lane because you're tired, FSD gently nudges you back, then suggests you take a break. It doesn't scold you with loud beeps. It helps. Or in bumper-to-bumper traffic for an hour, instead of constant brake and gas until your right leg aches, FSD handles it. You steer, you supervise, but your leg rests. And safety features you might not think about. If another car runs a red light and is about to hit you, FSD sees it before you do and hits the brakes. Industry data shows Teslas with active safety features have significantly fewer crashes than average cars. That's not marketing, that's real-world statistics.
Real-world range, what 200 miles actually means. Your comments show range is a major concern, and rightfully so. Let me give you the honest numbers, not the optimistic marketing. Based on leaked specifications and industry analysis, the Model 2 would likely achieve around 200 EPA miles of range. That's the official number tested in perfect conditions. But here's what that translates to in your real life. Highway driving at 70 to 75 miles per hour, expect 170 to 180 miles. Higher speeds mean more wind resistance, which drains batteries faster than city driving. Cold winter weather with heater running, around 140 to 160 miles. Batteries lose efficiency in cold temperatures, and cabin heating draws significant power. Hot summer with AC blasting, approximately 170 to 185 miles. Heat affects batteries less than cold, but air conditioning still reduces range. City driving in mild weather, this is where EVs shine. You might actually exceed 200 miles because regenerative braking recovers energy every time you slow down. Most people drive less than 40 miles per day. Even in winter conditions, 140 miles gives you 3 full days of driving before needing to charge. If you can charge at home overnight, range anxiety becomes largely psychological, not practical.
Charging, the home advantage. While everyone focuses on fast charging stations, let me tell you what actually matters. Level 2 charging at home. Charging overnight at home using a Level 2 charger is the cheapest and most convenient way to keep an electric vehicle powered. You plug in when you get home, and the car is fully charged by morning. Fast charging is primarily for road trips. For regular daily driving, grocery stores, visiting family, appointments, home charging makes electric vehicle ownership practical. For road trips, leaked specifications suggest the Model 2 would support charging speeds around 170 kilowatts peak. That translates to approximately 25 to 30 minutes from 10 to 80% charge at a Tesla supercharger. Compare that to budget competitors maxing at 50 kilowatts, requiring 70 minutes for the same charge. Here's the reality. If you cannot charge at home, electric vehicle ownership becomes significantly less convenient. Public charging works, but it's more expensive than home electricity and requires planning. Before committing to any EV, confirm you have access to home charging or reliable workplace charging. Without it, you're fighting an uphill battle. Tesla's navigation automatically plans charging stops on long trips based on current battery level, weather, elevation changes, and driving style. No mental math required. The system tells you exactly where to stop and how long to charge. Several comments mentioned concerns about charging infrastructure and broken stations. This is valid. While Tesla's supercharger network is the most reliable in North America with over 50,000 connectors, you will occasionally encounter broken stalls or stations under maintenance. Tesla's app shows real-time availability, which helps, but it's not perfect. Plan for occasional inconvenience. That's part of early EV adoption.
So we've covered design, safety, costs, and driving technology. Now let's talk about the question everyone's asking. When can you actually buy this car? Launch, timing, and what not to believe. Currently, Tesla has not officially announced a launch date or opened reservations for the Model 2. All information about timing, features, and pricing is speculation based on leaked sources, community analysis, and filed patents. This means if someone contacts you saying you must reserve now to hold a spot, that's not Tesla. That's a scam. Tesla always announces officially through their website and major media channels. They never request deposits through email, messages, or strange phone calls. If you're interested in the Model 2, the safest way is to follow Tesla's official website and wait for official announcements. Don't rush. Don't let anyone pressure you with phrases like "only 5 spots left" or "this deal ends today." Those are signs of fraud. Reasonable predictions about launch timing fall between late 2026 and 2027 based on production line construction progress and Tesla's historical timelines. But Tesla has a well-documented history of delays compared to initially announced dates. The Cybertruck was announced in 2019 and didn't reach customers until 2023. The Semi was announced in 2017 and started limited production in 2022. Patience is required. Be patient and don't believe any information that doesn't come from official Tesla sources. When Tesla is ready to take orders, it will be obvious, public, and announced through proper channels.
So now you know the complete picture about Tesla's rumored Model 2. Not advertising, not hype, just analysis based on the best information currently available from leaked documents, industry sources, and Tesla's established engineering practices. Here's the framework to decide if this vehicle, if and when it arrives, fits your needs. If you're tired of navigating touchscreen menus while driving at highway speeds, this car is designed for you. If you want assistance when you're tired but refuse to surrender control completely, this technology serves that exact purpose. If you're exhausted by the endless cycle of oil changes, transmission repairs, and unpredictable maintenance bills, electric powertrains fundamentally change that equation. If you need a car you can keep for 15, 20 years without watching it rust apart or require constant expensive repairs, durability engineering matters more than purchase price. But if your current car runs perfectly, if you're comfortable with your maintenance routine, if you have concerns about charging access or repair costs, then there's absolutely no reason to rush. This decision must be based on your specific situation, not pressure from anyone. Now, I need to hear from you, and I'm asking 3 specific questions.
First, do you want physical buttons back for climate and basic controls, or are you fine with touchscreens? Comment buttons or touchscreen. Second, for driving assistance, do you want help when you're tired but keep final control, or do you prefer full manual driving always? Comment assist or manual. Third, what concerns you most about switching to electric? Comment price if upfront cost matters most, range if you worry about distance, repair if insurance and repair costs concern you, or charging if infrastructure access is your biggest question. I read every single comment. Your answers directly shape what I cover in future videos. I'll pin a comment with these 4 options. Just tap and reply. If this analysis helped you understand what's real versus what's speculation, hit that subscribe button right now. We're building a community of people who want honest information about electric vehicles without the hype or the hate. Turn on notifications so you don't miss our next deep dive. Next week, we're investigating the Tesla Pi phone rumors. Can a phone that connects directly to Starlink satellites without needing cellular networks or Wi-Fi actually work? And if it does, how would it change communication for people in rural areas or those who travel frequently? The leaked specifications are wild, but are they real? I'll separate fact from fiction. Share this video with one person considering an electric vehicle, especially if they're over 55 and wondering whether these cars actually work for experienced drivers. That helps more people get access to honest analysis. Thank you for your time. Remember, technology should serve you, not the other way around. Drive safe, spend smart, and never let anyone pressure you into a decision you're not ready for.